Hey gang, here's your promised solutions to the lab on Tuesday. I'll try to be somewhat prompt in working these out for you. So for the first one, number one, the key is to visualize the function as 3x to the fifth minus 2x plus 1 all to the 1/2 power. And when you visualize it that way, then you can use the power rule, and you can say f prime of x is pull the half down, keep the inside the same. This is the generalized power rule. It's a half minus 1, so negative 3 halves. Then you have to multiply by the derivative of the inside, so 15x to the fourth minus 2. Technically, I mean, that's the derivative. You could stop. It's pretty common, though, with a negative exponent to go ahead and put that downstairs. And then I like to change this thing to an actual radical. So I'm going to write this as 15x to the fourth minus 2 over 2, and then I'll switch it to the radical of 3x to the fifth minus 2x plus 1 all cubed. I'm writing the cubed on the inside. You can actually write it on the outside like that if you want to as well. The rules of exponents say it's the same. So there's number one. All right, for number two, I'm going to need to do the product rule. So here we go. I'm going to think about this piece and this side as my two pieces. So I'm going to go f prime of x is, let's see, I'm going to take the derivative of this side. So I'm going to get a 4, 2x plus 1 cubed times the derivative of the inside. The derivative of the inside just kicks out a 2. So that's the derivative of the one side. Now you multiply by the other side. So I'm going to multiply by x cubed minus 5x squared. Then I'm going to go over and say plus. Now I'm going to write down the first term as is and write this as 2x plus 1 to the fourth. And now I'm going to take the derivative of this side. So I'm going to get a 2 times x cubed minus 5x all to the 1 power. And then I'm doing the chain rule. When I do the derivative of this side, I'm doing the power rule. And then I have to multiply by the derivative of the inside for the chain rule. And so I get a 3x squared minus 5. So you can, at the very least, you can move the 2 and the 8 over, the 2 over here. If you got this far in your lab and put the 2 there and combine things, that's fine. If you want to keep going and actually factor, let's take it one more step just for learning purposes here. Notice I've got a 2x plus 1 to the 3 here and then to the 4 there, so we share those factors. I share this factor as well. I share a 2. So I can pull a lot of stuff over, and I want to pull out all that I can. I can pull out a 2, a 2x plus 1 cubed, and a x cubed minus 5x. And then I want to write down what's left. So looking at this term, what's left? We got rid of that 2. We got rid of all of these. We got rid of one of those. So there's one of these left and then a 4. So I've got a 4x cubed minus 5x plus. Now I'm looking over at this side. I pulled out 3 of these, so there's one of these left. The 2's gone, this is gone, and then I'm left with that. So you're going to be left with a 2x plus 1 to the 1, and then a 3x squared minus 5. Let's actually write that as a parenthesis there. There we go. All right, so technically speaking, you could expand this out, combine like terms here, and make this a lot simpler. For time's sake, I'm not going to do that. I don't feel the need to do that here. I'll just put a dot, dot, dot. If you want to do that, you certainly can. I think I'm going to make a new page, and we'll just keep going. So that's 1 and 2. Let's do number 3 now. So for number 3, I'm looking at this and asking myself, what is this? This is a kind of a double composition. The outside function is this sine, and then I'm plugging in this guy. So I'm going to think about it just as one chain rule, if you will. Let's highlight this part. This is the inside part to sine. So if you think of it that way, then f prime of x is just 2 times the derivative of sine is cosine, plug in the inside, which we know is secant of x squared. That's it, okay, as far as the first step goes. Now you multiply by the derivative of the inside. So now I'm looking at this. Forget the sign. Just focus on this. take the derivative of the inside. When I want to take the derivative of secant of x squared, that's another chain rule. So we take the derivative of just secant, and we get secant tangent, plug in x squared. So it's secant of x squared and tangent of x squared, and then the chain rule says take the derivative of the inside again. Remember, I'm just working on this part now. The derivative of x squared is a 2x. And so I would definitely want to go ahead and move the 2x over and combine and write this as 4x cosine of secant x squared. And then I've got a secant x squared times the tangent of x squared. And just to be clear here, you can't combine these. This one is inside cosine, so it's sort of stuck. All right, that's number 3. Number 4. Number 4 was the one that everyone just seemed to absolutely love. I'm going to give a special color to 4 because it was so popular. Looking at this function, thinking about it, this is first and foremost a quotient. There's a quotient going on. I've got this part over this part. So I'm going to primarily do a quotient rule. But when I go to take the derivative of the top, there's a product right here. And there's also function composition going on right here. So you've got lots of stuff happening here. But it might be helpful, let's kind of to the side remind ourselves how the quotient rule goes. If you want to, you can't see the yellow. Let's get a new color here. I don't want to, purple. Okay, if I want to take the derivative of, let's say, the top over the bottom, the quotient rule says it's the top prime times the bottom minus the top times the bottom prime all over the bottom squared. So that's where we're at. And I want to do that on this nasty quotient. It's the derivative of the top. It's this top prime. That's going to be where the work is. Everything else will sort of fall into place. So here we go. F prime of x it's the derivative of the top. So we just jump right in, take the derivative of just the top. Maybe I'll highlight that for now. Okay, and now I'm focusing on a product rule. So there's a product rule going on. I have this side, and then I have the other side, the cosine thing. So the derivative of x is 1 times the cosine part, so cosine 2x plus 1, add x times, now I'm taking just the derivative of this part using the product rule. The derivative of cosine is negative sine of 2x plus 1. Okay, so I got the negative sign by saying the derivative of cosine is negative sine, plug in the same inside, but the chain rule says you need to go ahead and multiply by the derivative of the inside as well, and that actually kicks out a 2 there. And then the derivative, thank goodness for something positive, the derivative of pi is just 0. So that's the derivative of the top, this whole expression. Then you got to multiply times the bottom, and this is where we start to maybe feel the despair in our hearts, but we just keep going. I subtract the top now, x cosine of 2x plus 1 plus pi times the derivative of the bottom. Well, that's thankfully relatively straightforward. It's just a 2x all over x squared plus 5 squared. So if you got there, that's really great. Good job. I'm going to go ahead and put it in the form that Mathematica did. So a couple of things. I don't need this 1. I want to move this negative out and make the whole thing negative. I want to combine the 2 and the x. I might want to move this to the front, things like that. So just going to clean this up first and write this as cosine of 2x plus 1 minus 2x times the sine of 2x plus 1 times an x squared plus 5, and then we've got minus 2. Let's just push this negative and this 2x all the way through on this side, so we'll get a negative 2x squared cosine of 2x plus 1 minus 2 pi times x squared all over the denominator of x squared plus 5 squared. Okay, Mathematica broke this up. They put this part over the denominator, then they put this part over the denominator, and they ended up on the one side. You can't cancel the whole thing. I can't just cancel like that in general. But if I break it up, I can cancel an x squared plus 5 here. By the way, I actually wrote this technically wrong. It's a big parenthesis there. There we go. And so Mathematica sort of breaks it up and ends up with this over 1x squared plus 5, subtract all of this over everything. If that doesn't make sense, look back at your print off that you did in Mathematica. And now let's make it a new page just to make this easier. And let's do the last one, number 5. So I want to look at this and realize this is first and foremost a function composition. So I'm going to do the chain rule, and I'm going to get f prime of x is, okay, the derivative of tangent is secant squared. Plug in the inside. Plug in 3x plus 1 over 2x minus 5. Then you want to multiply by the derivative of the inside. So now you're focusing only on the inside, and I'm going to have to do the quotient rule. So derivative of the top is 3 times the bottom is 2x minus 5. Subtract the top times the derivative of the bottom is a 2 all over the bottom squared. So that's that. And I'm going to write this as a secant squared 3x plus 1 over 2x minus 5. And then what can we do upstairs? So we have a 6x and a negative 6x. Those cancel. I've got a negative 15 when I push this through, and then a negative 2. So I'm going to get, I think, a negative 17 if I'm doing that right, all over a 2x plus 5 squared. I don't think there's anything else that we can do. So that's it. Hopefully that's helpful. Hopefully that wasn't too fast. If you have questions, I hope that you'll feel free to reach out.